Card is drawn randomly from a standard 52 card deck. Find the probability of the given event. The first event is the card drawn is a king. Well, in a 52 card deck, there are 4 suits, and each suit has a king. So there are 4 kings. So the probability is 4 out of 52 or 1 out of 13. 1 king in every suit. Part B, the card drawn is a face card. The face cards are Jack, Queen, and King. So there are 3 face cards in each suit, a total of 12 face cards in the deck, reducing to 3 over 13 because there's 3 face cards in each suit. Card drawn is not a face card. Well, we can use the complement rule for probability. This would be 1 minus the probability that it is a face card. And this we have just computed is 3/13. And so the probability that it is not a face card would be 10/13. We have another problem dealing with cards, and I'm going to bring the sample down. And this time, it says a poker hand consisting of 5 cards is dealt from a standard deck of 52. Find the probability that the hand contains the cards described. Well, first of all, when you deal a 5-card poker hand, the number of ways that can occur is 52C5. And the number of ways that there can be 5 clubs this time would be 13C5, since there are 13 clubs, and the success would be that we have to have all 5 cards clubs. So there's several ways to compute this, as you know. I'm going to use the built-in combination computation in the graphing calculator. So I'll type 13 math, move over to the probability, 3 for NCR, and then 5, divide by 52, math. And notice I could use the left arrow once to get to the probability menu instead of the right arrow 3 times. I'm going to press 3 for NCR and 5 again. And when I press enter, I get 4.9519, etc., e to the negative 4. So in our decimal representation then, we'll have the decimal moving 4 places to the left, making 3 zeros, 1, 2, 3, 4, 9, 5, 2 is what that computes to be. So e to the negative 4 means that you multiply by 10 to the negative fourths. Move the decimal place 4 places to the left, so there are 3 zeros. Five cards from the same suit would be the probability that we had for clubs times 4. So 4 times 13C5 divided by 52C5. So going back to the calculator, I'll go 4 times second answer and get 0.00198808. And then the next part is 5 face cards. So there are 12 face cards in the deck. So we would have 12C5 divided by 52C5. Back to the calculator. So 12 NCR 5 divided by 52 NCR 5, enter, and we get 3.047 e to the negative 4, which gives us 3 zeros, 3.000347. And the last one in this problem, an ace, king, queen, jack, and 10, all of the same suit. This is called a royal flush. Well, there's actually one royal flush from each of the 4 suits. So we have to choose one suit out of 4, 4C1 divided by 52C5. 4C1 is just 4, so 4 divided by 52 NCR 5, enter. And this time we're going to see that we've got 1.5 times e to the negative 6. That means we've got 5 zeros out front. 1, 2, 3, 4, 5. 1, 5 are the other 2 digits. Since we're supposed to go accurate to 7 decimal positions. The last example here is not dealing with cards. It's dealing with CDs. And it says 3 CDs are picked at random from a collection of 17 CDs, of which 4 are defective. And so what is the probability that all 3 CDs are defective? Well, since there are 4 defective CDs, we would have 4C3. We'd have to pick 3 out of 4 of the defective CDs. And there are 17 CDs to pick from, so 17C3 would be our denominator. 4C3 is just 4, number of ways of picking 3 out of 4 items, and so 17C3 in our denominator or divided by NCR. I'm sorry, I forgot to put the 17 in there, so I'll back up there. 17, math, left arrow, 3 for NCR, 3, enter. And here we're only supposed to have 3 digits of accuracy, so this comes out to be 0.006. And the second part of the problem asks that all of the 3 CDs are functioning properly. Well, since we have 13 that are functioning properly, we'll be choosing from the 13 3 that are properly functioning over 17C3, and this will give us 13 math left 3 divided by 17 math left 3. And this gives us 0.421 as the probability to 3 decimal positions. I want to draw your attention to the graphing calculator just for a moment. In that last computation, in the middle of it, you see the 3 divided by 17. That division never occurs since the NCR operation pulls the 13 and the 3 toward it in the numerator and the 17 and the 3 toward it in the denominator. So parentheses are not required here.